Today we will solve osmosis and osmotic pressures. So these are some numericals. An aqueous solution of a protein has an osmotic pressure of 3.8 mm of mercury at temperature of 300 Kelvin. If the concentration of protein is 1 by 49.26%, weight by volume of the solution. So W by B percentage is given here. What is the molecular mass of the protein? You can use the formula, that is pi is equal to C into R into T. So pi is the osmotic pressure. So pi is given here 3.8 mm mercury. So we can write 3.8 divided by 760. And what is the concentration? So concentration is this is weight by volume. So weight is 1 by 49.26. And what is the molecular mass? That we don't know. And this is the molecular mass, concentration, and volume. So volume is 1000 and the weight of the volume is given 100 grams. So this much divided by 100. This is the whole is C, and R is 0.0821 and temperature is given here 300. So if you solve it, so on solving you will get here answer M will be equal to something, it will come about on solving. I got this answer, so this will be 1000. So answer is our D option is correct. Second question, 200 ml of a very dilute aqueous solution. So this is a very dilute aqueous solution, and of a protein which contains the protein weight is 1.9 gram of the solution protein. If the osmotic rise of such a solution at 300 Kelvin is found to be 38 millimeter of solution. This 38 millimeter of solution is not. So we have to convert in terms of mercury and calculate the molar mass of the protein. So this same question, pi equal to C into R into T. So this pi is the osmotic pressure, but this osmotic pressure is 38 millimeter of mercury. So first we have to convert in terms of mercury. This is a solution. So pi means we know that is 38, and you have to take density of solution as a 1, and in terms of mercury height is height we don't know, but 30.6 is the weight of height of the density of mercury. So what is the height of mercury is the actually pressure of this solution. So pressure of solution will be 38 divided by 13.6 in terms of mercury. This is the mercury, and convert into atmosphere 760, and C is the your concentrated solution. So it is given here 1.9 gram, and divide by molarity, and this is molarity, this is divided by molecular mass, and weight is given, volume is given 200 ml. So this is the 200 ml into 1000 is the concentration, and R is given how much? It is a 0.008, and right, so it is a 0.08 liter per atmosphere per mole per Kelvin. So take R, so R is 0.008, and if you multiply by into temperature, is given here 300 Kelvin. So if you solve it, so it becomes your M is equal to 62016 gram per mole. If you solve it, so you get the answer will be C is our sorry, it's not C, it is D is our answer. This value is our answer. Osmotic pressure of urea solution is 56.6 mm mercury and temperature is 10 degrees centigrade. The solution is diluted and temperature is raised to 40 degrees centigrade such that the osmotic pressure is found to be 31.3 mm mercury. What is the extent of dilution? So we have to find the extent of dilution. So there are two temperature and two pressure. So we can use the ratio. Pi is 1 is equal to we can write C1 R into T1, and pi 2 is equal to C2 R into T2. So initially pi is how much? 56.6, right? We can write 56.6, and this divided by not divided by concentration. C1 is given some concentration, that is C, and R, and temperature is T1 will be your 283 because Kelvin. 10 degrees centigrade. This is 10 degrees centigrade. This is your 40 degrees centigrade. Second pi is there. Second pressure is 31.3 millimeter. So 31.3 millimeter. So we can divide by 360 also. This also 760 millimeter. And C2 is given R, and temperature is given 40 degrees centigrade. This is with 330 millimeter. So if you divide it, this both, so on dividing, you will get 56.6 divided by 31.3. This will be cancelled out, and this will get your C1 by C2, and this will get 283 by 303 Kelvin. So if you solve, you will get C1 is equal to 2C2. This is the ratio. So if concentration of second solution is like it's doubled, so it is doubled, so we can say V2 is equal to 2 into V1. So this must be doubled. So if you see all our options, so our options carefully, so D is our, so VF, no, C, B is our answer. So B is double answer. This is double volume is given, so B option is correct. NaCl and calcium chloride, there are two substances and whose volume and most concentration is given. NaCl 1 liter 0.1 molarity, while calcium chloride is 2 liter and 0.25 molarity. Now you have to use these two solutions in such a way that the maximum volume of the solution can be prepared having Cl minus 0.34 molarity exactly, and both are strong electrolytes. So we can use the M1V1 formula. So M1V1 plus M2V2 is equal to M3 into V1 plus V2, right? This is the formula. So M3 is given 0.34 molarity Cl concentration. So M1 is given how much? So 1 into V1. So we have to find the maximum volume, and this will be your, that is 0.1 molarity already given here, and this is your 0.25 molarity, and this is your V2, and if you solve it, M3 is given 0.34 into V1 plus V2. If you solve, on solving, you will get 0.16 V2 is equal to 0.24 V1. So V2 is equal to 1.5 V1. So this is the ratio. Means V1 plus V2 is how much? It is 2.5 liter. V1 plus V2 will be 2.5 liter. So what is the V1? So V1, if you take 1 liter, and if you take V2 is equal to 1.5 liter. So this is the ratio. The total volume will be how much? So it will be your 2.5 liter. So answer, if you see carefully, answer is our A. Five number. Calculate the osmotic pressure of a solution prepared in the above questions if temperature is 300 Kelvin. So if temperature is 300 Kelvin and R is 0.08 liter atmosphere per mole per Kelvin. So in that case, what is the osmotic pressure of the solution? So osmotic pressure of the solution is pi into C multiplied by S into T. So this is S means R, CRT is there. So what is the pi value? So pi we have to find out. And what is the concentration? Now concentration we have one is Cl, one NaCl, and one 0.25 solution. So for concentration Cl we have 0.3 molarity, and one concentration is, we can write here 1 into 0.1 molarity, that is 1 liter into 0.1 molarity, and next is this is the mole divided by 2.5 liter, and next is your this liter 0.25 molarity. So 0.25 into 1.5 liter, because in this case V2 is 1.5 of 1 liter. This is the moles, and total volume is 2.5 liter. This is the whole concentration, and multiplied by R is given 0.08 and multiplied by 300. So on solving, you will get 12.72 atmosphere. So this is our correct answer for this question number 5. FeCl3 on reaction with the K4FeCN whole 6 in aqueous solution gives blue color. So color is giving blue, and these are separated by a semi-permeable membrane PQ, and you can see this this is the semi-permeable membrane PNQ as shown. And due to osmosis, what will happen? So both are aqueous solutions, so definitely this is semi-permeable membrane, and this will allow only water to flow in both the sides. See, water is flowing from here to here or here to here. So definitely the substance become blue in color. So water can flow on both the sides. So blue color formation on X, no, it is only Y also. So this is not possible. Only possible. This can be also possible. So A, B is the answer. You can see the C. Blue color formation of both the sides of X. Definitely this is the most correct answers. So answer in this question is only, we can see C is our correct answer. Human blood give rise to an osmotic pressure of approximately 7.65 atm at body temperature, that is 37 degree centigrade. Calculate the hence the molarity of the intravenous glucose solutions be to have same osmotic pressure as blood is. So the osmotic pressure of blood plus osmotic pressure of glucose both must be same. So what is the osmotic, what is the concentration of this glucose solution? So we can find out. So pi for blood is given 7.65. We can use pi equal to C into RT, and pi is given 7.65 atm, and concentration means we have to find out C, and next is R is given 0.08, and temperature is 37 means 400 Kelvin. If we solve C, so C will be equal to how much? So it will be 0.3 molarity. This is our answer. So answer is E is our correct answer. The relationship between the osmotic pressure at 273 Kelvin when 10 gram of glucose, that is P1, 10 gram of urea is P2, and 10 gram of sucrose is P3, that dissolve in 250 ml of water. So we know pi is proportional to, we can say your N, that is the number of moles of concentration. The moles is more, pi will be more. So pi for glucose, we can see N for glucose is what? So for glucose, if you find out, this will be 10 divided by, formula is T, and N for, you can say urea, it will be 10 by 60, and N for sucrose, so it will be your 10 by 340 T. So definitely concentration of urea will be more than concentration of, you can say, next will be your glucose, and next concentration of this will be your sucrose. So this is our ratio. So pi will be also more. So this is P2, and this will be your P1, this will be P3. So this is our ratio. So if you see answer is our C. Equal volumes of 0.4 molarity glucose solution this temperature and 0.6 molarity fructose solution at this temperature are mixed. So when you mix it without change in temperature, I mean temperature is constant. If the osmotic pressure of glucose, fructose, these two solutions and mixture are pi 1, pi 2 and pi 3 respectively, so you have to find the ratio. So first we find the pi 1. So pi 1 is equal to, that is the first case is 0.4 molar concentration, that is the C1 solution. And next is your pi 2. So first is C2, this is the C2 solution. C2 solution is how much? It is your 0.6 molarity. So this is your fructose and this is your glucose. And mixture, so we can say pi 3 is mixture. So mixture means equal volume we are mixing. So C1 plus C2 divided by 2. So 0.4 plus 0.6 by 2. So it becomes your, so half of this one is 0.5 molarity. So first 0.4, 0.5 and 0.6. So we can say pi 1 is lesser than, next is your pi 3 and next is your pi 2. This is our relationship. So if you see carefully which is the answer is your C is our. Which aqueous solution has the highest osmotic pressure at 25 degrees centigrade? Assume all ionic compounds are completely ionized in water. Means it is 100% soluble. So it will depends upon the I factor, I into C factors. C is given, I you have to find it from here. You have 100% dissociation. So if you see A will be your how much? So if you see I1 into C1, that is 0.1 into 3 plus 2, 5. Second B will be 0.1 into 2 plus 1 3, and C will be 0.2 into 2 factors, 2 is there, and D will be 0.3 into, so it is your only one factor. So if you all consider which have highest concentration, so definitely we are getting ammonium sulfate is